Hello all, I would like to welcome you all in the playlist of Basic Electrical Engineering. In this session, I'll be discussing about analysis of AC circuit through RC series circuit. First of all, we have to consider the circuit diagram and later we'll explain the phasor diagram, what about the impedance and power, calculation of power factor, phase angle, etc. Let's get started. Before starting the session, I request everyone to subscribe this channel. If the particular video is useful, kindly share with your friends and colleagues. First of all, we'll understand what do you mean by a series RC network or a series RC circuit. A circuit that contains pure resistance R in which is in ohms and which is connected series with the pure capacitor of capacitance C farads, which is known as RC series circuit. Simple, R and C both are connected in series. Okay, if both R and C connected in series, then we will come to know that the same current I flows through both resistor and the capacitor. Am I right or not? Because it's a series circuit, no? So the same current will be flowing through the circuit, but the voltage across resistor and the capacitor will be getting divided. You know the basics of series circuit. Now I will show you the circuit diagram of RC series network or RC series circuit. Yeah. So please have an observation here. We have resistive element and the capacitor element. Both are connected in series. And the same current I is flowing through resistor and capacitor. But the voltage across resistor and the voltage across capacitor, that is different. So it is mentioned it as VR and VC respectively. But the total voltage can be written as V. Therefore, V can be written as the sum of VR and VC. Hope you are getting my point. Because it's a series circuit, no? Yeah. So, see. Therefore, we are applying a voltage of VC equal to Vm sin omega t, where Vm is the maximum value and a small letter v is the instantaneous value. Omega is the angular frequency. These are the points you need to know. Let's go ahead. So, what you can do is you need to draw the phasor diagram. So, it is better to draw the phasor diagram to understand the circuit very clearly. You know that it's a series circuit, the same current I flows through that. So, let us take I as a reference. When it comes to a resistor, this is your resistor element. So, in case of resistor, what is the speciality? Both the current and voltage, both are in the same phase. So, therefore, I would like to mark VR. What is the angle difference between VR and I? It will be 0. I hope you are getting my point. When it comes to capacitor, what did you understand from the capacitor? I have already explained one video regarding the behavior of capacitor in an AC circuit. In case of capacitor, the voltage is getting lagging compared to current. Compared to current, voltage is lagging. If it is an ideal case, voltage lags behind the current at an angle of 90 degree. So let me ask, how will you represent VC? VC means voltage across capacitor. As I told you that compared to current, the capacitor voltage is getting lagging. Am I right or not? Yeah. Therefore, what you are supposed to do is, here you can able to mark like this. Compared to current, this is your current through the capacitor. So, it is better to draw the voltage across the capacitor like this. Okay. So, for ideal case, we will be taking it as 90 degree. Fine. Therefore, what could be the resultant voltage? So, let us draw the result like this. This is your VC. Then resultant voltage will be V only. This is your resultant voltage. This will be VC and this must be VR. Okay. The angle between the resultant voltage and the voltage across a resistor, that is represented as phi. Okay. Then you can able to form a triangle like this. Clear? Okay. Now what you can do is, this triangle you can able to modify like this. So VR means we can able to write VR is equal to I into R. Okay, I into R. Likewise, what we can able to write? VC. VC means I into capacitive reactance, that is XC. XC. Similarly, total voltage is equal to I into impedance. Impedance is the total resistance. So, I is a common factor. If you want, you can draw like impedance triangle. Resistor is here. This is your capacitive reactance. This will be the impedance. Like this, you can able to mark. Hope you understood. Now you can able to represent in this fashion. So please you can take the voltage as a reference. See, V is equal to Vm sin omega t. I am representing the voltage starting from 0. See, this is your 180 degree or pi degree, and this will be 2 pi. Correct? Radian. Better expressed in terms of radian. And now, what about the current? So, compared to voltage, current is leading, or compared to current, voltage is lagging. Anyway you can able to represent. Yeah. Now here what they have represented is I can be written as I is equal to Im sin omega t plus phi degree. So here current is leading now. Compared to voltage, current is leading. Or else you can say compared to current, voltage is lagging. Anything is okay. Okay, please don't get confused. Now current is equal to Im into sin omega t plus phi. So where should I start the current? Yeah, it is leading now. If it is leading because it's a capacitive circuit, current is leading. So instead of starting from 0, it is starting from higher angle. Okay, so it will be marking in this fashion. So current will be marked in this fashion. Look at this, it is very clear. Fine. So you can draw in this fashion. Current leads. So this is actually the Phasor diagram. Moving forward, how to calculate the impedance? Let us consider the impedance triangle. So resistor, then inductive capacitive reactance Xc, Z is the impedance. Therefore, apply the Pythagoras theorem. See, voltage is equal to square root of VR square plus VC square, or else we can able to write it as square root of VR means I into R, IR square plus minus I into Xc. Minus means it is in the downward direction. Yeah. Therefore, we can able to write that voltage is equal to current can be taken into outside I into square root of R square plus Xc square. Therefore, we can able to calculate the current I is equal to V divided by square root of R square plus Xc square. Therefore, we can write V divided by Z, where impedance is equal to square root of R square plus Xc square, where Xc is equal to 1 by C omega. Omega can be written as 1 by C into 2 pi f. 1 by C into 2 pi f. I hope it is clear. Yeah, only this impedance, how to calculate the impedance. And also you can able to calculate the phase angle. How do you calculate the phase angle? So take the same triangle. So tan phi can be written as, how to calculate tan phi? Opposite side. Xc is the opposite side. And which is the adjacent side? R is the adjacent side. Or else you can able to write it from this triangle also. Anything is fine. Therefore, phi can be computed taking the tan inverse of Xc divided by R, where Xc is known as capacitive reactance, which is expressed in terms of ohm only. What is the unit of resistor? That is also in terms of ohm. Hope you are getting my point. So this also you have to remember. Now I will be discussing how to calculate the power consumed in an RC series circuit. Let V is equal to Vm sin omega t. Current can be written as Im sin omega t plus phi. Therefore, what you can do, power is equal to, so you can calculate the power that is given, instantaneous power is given by P into P is equal to voltage times current. Now do substitute 1 and 2 in this equation. Therefore, power can be written in this fashion. So power is equal to Vm sin omega t into Im sin omega t plus phi. Therefore, we can write Vm Im divided by 2 into sin omega t plus phi plus sin omega t. This is for the convenience, because 2 and 2 will be obviously cancelled. Just for the convenience I have written in this fashion. So Vm Im by 2 can be written as Vm by root 2 into Im by root 2. And 2 let it be as it is. So sin omega t plus phi into sin omega t. This formula you have to apply here. Remember this formula. Then I can able to elaborate in this fashion. So Vm by root 2 into Im by root 2 into cos phi minus Vm by root 2 into Im by root 2 into cos 2 omega t plus phi. If you take the average value, obviously one thing I want to tell you, this term will be 0. Only Vm by root 2 into Im by root 2 into cos phi will be existing. So what is Vm by root 2? Vm by root 2 means Vrms. Im by root 2 means RMS value of current. Okay. So let us modify. So I will be writing like this. P is equal to Vrms into Irms into cos phi, or we will write it as Vi cos phi. So where power factor can be written as Vr divided by V, that means R by Z. So if you substitute 3 and in the previous equation, I will be getting the total power dissipated in the circuit is equal to I square into R. Clear? So power can be represented in this fashion. So first of all you have to mark the current. See, current is actually leading, and you can take the voltage. So if you multiply voltage and current, you are able to get the power. This will be the power. Am I right? Yeah. So I have referred the following textbooks, and you may also go through the particular textbook to get the more information. Next video I am going to solve some more numerical example. Thank you for watching this video. Have a great time.